Welcome back to Newmber Math, in which we apply color to identify and sequence within math, because in math we work with 3 steps: identify what we're working with, recognize which formula to use, and sequence through. Okay, for the first 4, we will be working with binomials and trinomials. Wonderful, let's kick it off. What is the result of, binomial, just like a bicycle has how many wheels? 2. Yes, a binomial has 2 terms. Okay, 2x minus 5 and another binomial of x plus 9. Now, if we look at number 2 and number 3, I have pre-highlighted that subtraction in this plus in gray because things are different. Okay, now here we notice, there's nothing in between on Gray Street. Okay, what does that tell us? We need to distribute. We need to multiply each term in binomial 1 to each term in binomial 2. So let's just begin. Okay, our first term in binomial 1 is 2x. We need to take that 2x and multiply it to x. Well, 2x times 1x gives us, 2 times 1 is 2. Okay, now our x values here, we will add the imaginary exponents of 1, giving us 2, making this 2x squared, or 2x to the second power. We will then take our 2x, multiply it to 9. Well, 2 times 9 is 18. Don't forget the x. Wonderful job. And then we will take our second term in binomial 1, which is negative 5. Wonderful. Negative 5 times x gives us negative 5x. And then negative 5 times 9 gives us negative 45. Wonderful work. From here, it's just now simply an expression. We need to combine like terms. I will go ahead and I will circle my 2x squared, and I will look down the road. Is there anything I can combine it with? Well, these do share an x, but they don't have an exponent of 2. So our 2x squared just stays the same. And then I'm looking now, I will box my plus 18x, separate group, and I can definitely combine that with our negative 5x because they share the same variable x. No exponents included besides the imaginary ones. If I started with 18x, I took away 5x. How many x do we have? Yes, wonderful job. 13x. And our negative Jordan of 45 just hanging out. Well, bring it on down. That right there is your final answer. Let's go ahead and search for it. 2x squared plus 13x minus 45. You will circle D as your answer choice if that is what you have. Moving on to number 2, it says, what is the result of, trinomial has 1, 2, 3 terms, just like a tricycle has 1, 2, 3 wheels. And since we have the addition sign in between both, we will just simply align and combine to simplify. Okay, we will just line up the like terms. We will start with negative 4x cubed. Wonderful. We will align that under 7x cubed, because they share the same variable x and they're both cubed or to the third power. Then we will take our plus 5x squared and drop it and align it right below our negative 2x squared. From there, we will take the negative 13 and boom, align it right below that negative 2. Draw yourself a little bit of a line. 7x cubed minus 4x cubed gives us 3x cubed. I'm just going to zoom out for a moment because once we have combined one set of like terms, what do we notice? B is our only answer choice. However, let's just go and work through. Negative 2x squared plus 5x squared still gives us a positive 3x squared, and negative 2 minus 13 gives us negative 15. Again, B is your answer. Max completes the following problem. Negative 13 minus 30i. Whoa, a minus, a subtraction symbol, and it followed by another binomial of negative 9 plus 11i. His result after the first step was negative 13 minus 30i plus 9 plus 11i. Is his first step correct? Explain. Well, let's see and find out. Okay, so instead of an addition, we have a subtraction symbol. So binomial 1, Nothing changes. Okay, so negative 13 minus 30i, what I'm going to do is simply align it right under Max's answer of negative 13 minus 30i. Okay, now let's just complete what we need to do. All right, I will switch to blue. Now, we just distribute the negative to both terms in binomial 2. Basically, just flip the signs because a negative times a negative becomes a positive, and a negative times a positive becomes a negative. So we will write plus 9 and negative 11i. So plus 9, negative 11i. And is his first step correct? Explain. Well, let's go see. Negative 13, negative 13, negative 30i, negative 30i, plus 9 and plus 9, plus 11i and negative 11i. No, it's not the same. So eliminate two answer choices right away. Boom, boom. And let's take a look at answer choice B. No, he should have not eliminated the parentheses. Okay. Has to be C. Let's give it a check. No, he did not distribute to both terms in the second parentheses exactly because he never distributed to the 11i. Go ahead and circle C as your answer choice. And for number 4, another tip built in before we begin, okay, I squared equals negative 1. So examples are, if we end up after distributing with, let's just say, negative 24i squared, well, negative 24i squared is equal to negative 24 times negative 1, which equals 24. 15i squared equals 15 times negative 1, which equals negative 15. Basically, flip the sign of the coefficient and ditch the I squared. Okay, so let's just go ahead and let's take a look at this and let's see what we have. Okay, we have a 7. There's nothing in between. There's no addition or no subtraction. That means we need to distribute. And we will start off with 7 times 3. I'll write this right below, giving us 21. 7 times 3i gives us plus 21i. I will switch to red, and we will be looking at negative 6i times 3, giving us negative 18i. And then we have negative 6i times 3i, giving us negative 18i squared. And what did we say? Basically flip the sign of the coefficient and ditch the I squared. So what we will do is instead of negative 18i squared, we will flip the sign and make it positive 18i squared. Ooh, and then we will just get rid of the I squared. I will simply do that. Then I will go and look to combine like terms since we now have an expression. I will circle my 21. Are there any numbers that just stand alone by themselves? Well, let's see. This has an I, this has an I. Oh my goodness, we got rid of the I squared. Go ahead and circle your 18. 21 plus 18 is 39. And if we look at our answer choices, we could simply just stop right there and circle C. However, let's go ahead and box our other two terms of 21i. Take away 18i. What do we have left? Yes, we do. 3i, and everything aligns. Moving forward. Okay, Julio and Connie are playing a game. Julio's game piece is at the point 11, negative 4. Connie's game piece is at the point 9, negative 1. What are the coordinates of the point midway? Ooh, the point midway between the two game pieces. Well, if I'm looking for the point midway, I'll probably use the midpoint formula. Okay, x1 plus x2 divided by 2. That will give you your x for your midpoint. And y1 plus y2 divided by 2 will give you your y for your midpoint. Let's go ahead and label these bad boys. x1, y1, x2, y2. Now, if we will add our x1, which is 11, plus our x2, which is 9, we will do 11 plus 9 divided by 2. 11 plus 9 is 20, and divided by 2, that equals 10. I will easy bake oven, set it and forget it while we find our y value. Okay, we will do y1 of negative 4. We will add that to y2 of negative 1. We will set that over to, well, negative 4 plus negative 1 is negative 5. Divided by 2 equals negative 2.5. Go ahead and circle your answer of B. All right, very quick one for us there. Moving forward to number 6, again, should be another quick one. I'm not even going to bother to color code because we've been over it before. And I do have notes that are color coded that I did post already. So let's just take a look at it, okay? Now, when we work with scale factor, actually, let's just read it real quick. Sorry about that. Determine the scale factor of the dilation below. Okay, so a dilation, all right, an image is going to be getting larger or smaller, or should I say our pre-image. Whoa! All right. However, in order to find our scale factor, all right, we need to take a side from the image. Now, the image has the dashed lines, or if we zoom in tight, do you see how that H has an apostrophe? That would be H prime. Okay, and then we take that and we put it over a corresponding side of our pre-image, which is our solid line here. Okay, so if I'm going to, let's just say, take H prime to J prime, well, H prime, J prime equals 5. We need to put that over HJ. Well, HJ is represented by a 10. And if we need to reduce, let's see, 5 over 10 equals 0.5. Oh my goodness, they're only giving us fractions and whole numbers? Well, we know it's not A and we know it's not B. What if we get confused? How do we see? Okay, well, simply 5 divided by 5 is 1. 10 divided by 5 is 2. Go ahead and circle your answer. And moving forward now to number 7. All right. What is the length of DE? Okay, now these are similar triangles. They're telling us that as we are looking for the length. Okay, so here is what you will do. We can set up proportions. All right, that'll be the first way. And doing that, what I'm going to do is, well, let's just take a look. I will take my X. Okay, now if we can see, let me zoom in. Not zoom in, but let me get my other highlighter out. All right, so DE goes from 2 arches. If we look inside of angle D, or that corner right there, we have 1 arch and 2 arches, and that goes to 0. All right, I'm also going to begin to set up the proportion of X over, ooh, I don't like that, the corresponding side. Now, count the arches, 2 arch, because to 0, this triangle has turned a little bit. All right, so if we go from 2 arch to 1, that doesn't work. 2 arch to 0 arch. All right, so see that and know that, recognize it, and you'll be fine. All right, we will set that over 6. Let me go ahead and pen that in. And then we will set that equal to what's left from each triangle. All right, so what we have left from each is, sorry about that, working on my colors here, 15. Now, if we started from the numerator, from this triangle, the numerator has to come from the same triangle when you work your proportions. Thank you. Do not confuse this. This is where I see a lot of students kind of get confused, is actually setting up the proportions with corresponding sides. But truly, guys, it's not that difficult. Identify, okay? 15, we'll set that over 7.5. From here, we will simply cross multiply. All right, let me grab my red. I always like to start with the X's. I'll actually grab my green to change colors after I fix my 5. Okay, I always like to start with the variables. All right, I want to do X times 7.5. Well, 1X times 7.5 simply just becomes 7.5X. We will set that equal to, I will highlight in brown right here, 6 times 15, which equals, yes it does, 90. Great job. And then from here, all as we are going to do is simply divide by 7.5. What we do to one side, yes we do to the other. We see that equal sign, we know we have an equation. Wonderful. Okay, and if we do the math correctly, X equals 12, giving us our side length. Oh my goodness, look at 12. Beautiful. Now, here is one more way to do it. that I want to offer you when working with this and solving, okay? I'm going to flip colors. Now, if I know that I'm solving for this triangle because it has the variable, well, I can take that side of 15 and I can simply divide it by its corresponding side, which we've already identified as 7.5. That equals 2. Now, 2 is what they call our scale factor. All right, now, when we know that triangles are similar, well, all sides are proportional, meaning they all share the same scale factor. Okay, so 15 divided by 7.5 is 2, and if we take 2 and multiply it by 6, well, let's see what happens. Let's multiply it by that red 6, and what do we get? Yes, it does. It equals 12, which equals x. Oh my goodness, we have the same answer. So in all reality, truly, that's all you need to do. Just identify. If we know they're similar triangles and they all will be proportional and share the same scale factor, they're all being multiplied by the exact same number. All right, let's go ahead and move forward. For number 8, I'm going to show you the scale factor route. I'm not going to waste any time even identifying similar triangles because I go straight to answer choices and I start looking. Well, DB, all right, wow. They're all different answer choices for side length. And side CB, they're all different answer choices for side length. We will solve via scale factor. You have the proportions in classroom. I've covered them multiple times. All right, on a test like this or in a test like the SAT that's standardized, and when we can look at something and take what we know and apply it, always go with the faster route. Okay, so what I know is that we're definitely solving for this triangle because they both have side lengths represented with a variable. So these side lengths we don't know. All right, but we do know what CD is, and CD is 10. And that corresponds with, oh my goodness, 3 arch to 2 arch, 3 arch to 2 arch, the 4. So all we really need to do is 10 divided by 4, which equals 2.5. Okay, we can take that 2.5 and we can pick either one of these, the 6 or the 3. Sure, you want to go with the 6? No problem. All right, we will take it. Now, I also do want to highlight this. Hold on. So side AB that's represented by that 6, that corresponds with side BD or side DB. All right, so just know that when you multiply this 6, it does go with side DB and not side CB. All right, we can also count the angle arches. Angle A has 2 arches, goes to B with 1. Angle D has 2 arches, goes to B with 1. All right, so I just wanted you to know that. Now, let's just multiply 2.5 times 6 equals 15, which equals DB. And if we find DB equals 5, DB equals 12.5, DB equals 15, go ahead and circle C as your answer. Move on to the next one. It's a simple divide and multiply. Thank you, scale factor. Okay, are the two triangles similar? Why or why not? Okay, we should know these by now. If not, quick refresher, angle, similarity. They need to have 2 pairs of corresponding angles. And right off the bat, we know they have at least 1 pair because we have angle B here with 1 arch and angle E has 1 arch. So I'm just going to go ahead and put, well, angle B is congruent to angle E. Wonderful. Are there any more pairs? There is. Great call. Amazing job, guys. Our C here is represented in both of these triangles. And what do we know about that? Yes, they are vertical angles, and vertical angles are congruent. So angle C is congruent to angle C. Okay, yes, they're similar because of side. Yes, they're similar because of angle. I know that D is the same exact answer choice. I don't know why. So if you circled B or D, at least on the review, 100% it's correct. Okay, so know that when you see this, you have to recognize that C right here, vertical angles, so they are congruent. take it what each of these questions is giving you and just apply what you know. All right, so based on your knowledge of similar triangles, which statement would justify triangle ABC is similar to triangle DEF? Well, we can take the long route home, and let's just go ahead and take a look at it quickly. All right, I will go ahead and highlight that C. That has one arch, but take a look. Oh my goodness, E has two arches. We do not have a pair of congruent angles. That's okay. So what we'll do is, let's take a look at something else. And right away, real quick, just to show you, okay, if we do not have one pair of congruent angles, anything that has an angle within the answer, side angle, side, get rid of it. We don't even have one pair of congruent angles. Angle, angle, a hard no. That leaves us two answers. It is not possible, or D, side, side, side. Well, take a look. Side, 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 side. So odds are that is going to be our answer, but we do have to check for proportions. Okay, what I like to do is, compliments to Miss M on this one, I will take the largest number in the largest triangle, or the greatest number from the larger triangle of 56, okay? Then I will take the greatest number from the smaller triangle of 14. All right, 56 over 14 equals 4. Okay, actually, I want to make that in blue, all blue. Sorry about that. I actually want you guys to see that I'm taking the greatest over the greatest. Thank you. That equals 4. All right, now we will take the mid number. We'll do that in red. And now our mid number is 52, and then we have a 13. So we will take 52 over 13 equals 4. We will do that one more time with 48 and 12. And yes, 48 over 12 is equal to 4. This is proving that all three sides are proportional, and again, sharing that same scale factor. Thank you. Circle D, side, side, side is your answer choice. But guys, take what it's giving you, apply what you know. All right, number 11, which statement would justify triangle BAC is similar to triangle DAE? Well, let's go ahead and take a look. So it's asking us BAC, all right. We'll do this one in blue. Actually, you know what? I will, but I'm going to just a hair slim it down. All right, we have BAC. Then it's asking us, similar to DAE. Well, let's take a look. Let me thin this out now. DAE. Oh my goodness. I'm going to put this in red here, right on the inside. All right, so you're telling me because of the side splitter that we have a smaller triangle within the larger triangle. Yes, and what do we know about that? Exactly. They both share this angle of A. Okay, so there's already a congruent pair of angles. Okay, so angle A is congruent to angle A. All right, now if we look down A, well, both the smaller triangle and the larger triangle, it's giving us side lengths, okay? So basically we have a side, we have an angle that's smushed in between two sides, giving us side, angle, side for both of them. Now the notes in classroom are a little different. They're more thorough, but as a quick refresher for those that may be struggling a little bit, go ahead, take this, utilize it as an extra reteaching tool. All right, for number 12, triangle ABD is similar to triangle ECD. What is the length of DE? Well, let's just go ahead and put an X right here. Now, we can again do proportions, or we can do scale factor. All right, so just to let you know, we can do it either one of two ways. All right, we'll go ahead and we'll set up our proportions. All right. So DE here is going to correspond with EA. So we're going to take X and put it over 18 when we set this up. All right, it's going to be tough for me to keep going back and forth with the colors quickly for a 30 questioner. So just to let you know, I might kind of veer off just a little bit. All right. Then if we took from the smaller triangle, okay, we have to use that as our numerator as well. So x, smaller triangle, numerator, 3.5, smaller triangle, numerator. Oh my goodness, I'm not even switching back to the pen. It's just in highlighter mode. We will set that over 12. Great job, great call. You guys are amazing. From here, again, we will just cross multiply. Again, I like to start with the variables. 12 times x gives us wonderful 12x. We will set that equal to, amazing job. Let me get my brown highlighter out. Ooh, I'm going to need a sip of water. Wow, I needed a commercial break bad right there. However, the officials did not whistle one in for us. And let's continue. 18 times 3.5 is going to give us 63. From here, you know what to do. Divide each side by 12. We get x equals 5.25. Go ahead and circle your answer. Now, you also could have done it a couple of different ways. If we know that we're missing this side, its length, we could have done 18 divided by 12 times 3.5. And just to show you, 18 divided by 12, okay, hit enter, times 3.5. What does it give us? Exactly 5 1/4. You also could have done 3.5 divided by 12 times 18. All three ways, 2 scale factor, 1 proportion, all give you the same answer. All right, so for number 13, triangle ABC is a right triangle. Find the length of x, which is the altitude. Oh my goodness. I love it. I love that they're giving us exactly what things are. All right. If we know that our x is our altitude, we can simply set this up, all right, as x squared equals side times side. So let's just go ahead. Let me get my gray out since we highlighted that in gray. Equals, and then we will just do side of 20 times our other side. We'll put that in green of 45. Okay, so then we will get x squared equals 20 times 45 will give us 900. From here, okay, to get x by itself, we have to take the square root of both, giving us x equals 30. Go ahead and circle your answer. For some of these problems, I left the color-coded notes built in. One, to just give you, especially for this one, both ways to solve. Also, to assist you with identifying when reading through the word problem, okay? The length of a light pole's shadow is 120.4 feet. So here's our light pole shadow. I made a flagpole because I grew up playing Mario Brothers. And at the same time of day, 2.4 foot tall shrub. Okay, there's our little shrub there. Casts a shadow that is 4.8 feet long. What is the height of the pole? Well, that we don't know. Again, we can set up 2 ways to solve. 1, proportions. 2, scale factor. 1, proportions. Again, I always like to begin with starting with our variable in the top left. Okay, so I just drop that there. Then I look for its corresponding side, which is 2.4. Set that right below. Equals to, now if we took from our pole first here, okay, we will also do the same and drop that into our numerator. So our 120.4, set it over the 4.8. Okay, from here I simply cross multiplied x times 4.8, giving us the 4.8x equals 2.4 times 120.4, giving us the 288.96. All right, you guys are definitely clear on sequencing. We divide each by 4.8, we get x equals 60.2. We also could have done 120.4 divided by 4.8 will give us our scale factor. From there, and let's just do that real quick in here as I just had it up, but I was like, whoa, let me run through the calc. 120.4 divided by 4.8, hit enter. Okay, from here, you're like, oh my goodness, 25.08333. Nope, don't even worry about it. Hit times. All right, put in 2.4, hit enter. Boom, you have your answer of 60.2. All right, I definitely recommend drawing this out just so you can see it yourself. Moving forward to 15. Again, I left some things in because I just feel like it really benefits us. A couple of key things you might want to take right away. Vertical angles are congruent, as we can see. And let me read through. So find the measure of angle 4. Okay, so we're looking for 4. In the diagram below, if measurement of angle 2, it's giving us, equals 8, and in parentheses, x plus 8. And measurement of angle 4, okay, equals 2, in parentheses, 5x plus 24. A little bit of distributing going on there, but as we can clearly tell, 4 is a large obtuse angle, and 2 is a large obtuse angle. Okay, and 1 and 3 are the smaller ones, so 2 and 4 are vertical angles. That means we will set it to angle equals angle. 1 and 3 are also vertical angles. Okay, now that we know that, let's just go ahead and take a look. Our measurement of angle 2 is 8, and then in parentheses, x plus 8. We follow the formula here, and then we just set it equal to the measurement of the other angle it's providing for us, which is 4. All right, 2, open a parenthesis, 5x plus 24, close it. 5x plus 24, close it, and now we will just simply sequence through. All right, let's work it out here. We will distribute first when we have the parentheses, distribute the 8 to both terms. 8 times x gives us, wonderful, 8x. 8 times 8 is, yes, you guys are on fire, 64, equals 2 times 5x, which is exactly 10x, and 2 times 24 equals 48. Great job. Okay, now from our last Unit 5B quiz, okay, we know that if we jump to step 2 now, all right, we will move the term with the variable with the least value that we divide by a positive in the grand scheme of things at the end. All right, little tip from Mr. P there. 8x minus 8x, get rid of it, or 64. Yes, it does come down. Bring down your equals. 10x minus 8x gives us the 2x. Bring down that plus 48. Excellent job so far. Okay, we have a constant alone by itself on the left side of the equal sign hanging out, which means we need to get the term with the variable by itself. And what's hanging out with 2x? Exactly the plus 48. And how do we, I don't even need to say it anymore, thank you, subtract 48, but not just from one side. We do that to both. 64 minus 48 equals 16. Bring down your equals, bring down your 2x, cross out your 48s, and what's the last step? Thank you very little. Divide each side by 2, or the coefficient of the variable, the number in front of the letter. 16 divided by 2 equals 8. Bring down your equals, leaving us just our x. However, are we done yet? No, we are not. All right, we need to plug in. Now, you can plug in for either of these because they're congruent, and we already knew that because it's angle equals angle. Instead of having to write some double parentheses in my calculator, I'm just going to go ahead and plug into angle 2, because when I see that x with no coefficient, to me it's just a lot simpler. All right, so let's just go ahead and do that. It had an 8. We open a parenthesis. We drop our other 8 in there. All right, and then it says plus 8. Because it was x plus 8, we know what our x is. Equals, we can put that into a calculator. All right, we can just do 8, open parenthesis, 8 plus 8, close, enter, equals 128 degrees. Go ahead and circle A as your answer choice. Didn't mean to zoom out that far. Moving forward to number 16. All right, in the diagram below, angle 1 and angle 2 are a linear pair. What do we know about linear pairs? Yes, they are supplementary. And take a look, we only have 2 angles on that line. We have angle 1 and angle 2. Okay, they're clearly different in size, meaning they're supplementary. Angle plus angle equals 180. We're looking to solve for 1. And let's just go ahead and write this out. The measurement of angle 1 is 2x minus 6. We will add that to the measurement of angle 2, which is 4x plus 6. We will set that equal to 180 because, again, we're just following the formula. Okay, from here we will, look at that on the left side of the equal sign, all these terms. Yes, we get to combine a couple of groups. I will circle my 2x, and what can we circle with that 2x? Yes, we can, that plus 4x. And if I started with 2x and I added 4x, how many x do I now have? Exactly, I have 6x. Then I'll box my negative 6 and I will box my plus 6, but if you owed me $6 and you paid me back $6, well, you don't have anything left. I'm just going to go ahead and cross those out right there so we don't even have to deal with it. Equals 180. Oh my goodness. We have a term with a variable on the left side and just a constant on the right side. Yes, we can. Simply divide. Each by 6x equals 30. No, we are not done yet. We have to plug in. It wants the measurement of angle 1, and since they're supplementary and they're two different sizes, we have to plug into 1. So 2x minus 6, let's go ahead and rip that real quick. 2 times our x value of 30 minus 6. Put that into your calculator, and yes, you will get 54, as I've already had it circled from a previous one, but go ahead and circle that as well. You now have it solved. Moving forward to 17, yes, we are going to continue with this stuff for a little bit. I know it gets old in the diagram below. L is the transversal of the parallel lines M and N. Find the measurement of angle 5. Woohoo! If the measurement of angle 3 equals 3 open parentheses, 2x minus 3 close, and the measurement of angle 5 equals the expression of 3 open parentheses, 4x plus 3. All right, so I did highlight 3 and 5 in gray because that's what it's giving us. And as we can tell, 3 is less than 90 and 5 is greater than 90. Okay, so they're definitely supplementary. I think I also built in a little note for you. Feel free to take that down if you'd like. Same side interior angles are supplementary. Angle plus angle equals 180. And again, guys, use your visual awareness as well. It's really just all there for us. So let's go ahead and set this up then. 2x minus 3. All right, plus 4x plus 3. A lot of 3's. All right, set that equal to 180. And again, we have to distribute. 3 times 2x is 6x. 3 times negative 3 is negative 9. 3 times 4x is 12x. And 3 times 3 is 9. Set that equal to 180, and very similar as the one we just did prior. Yes, we need to combine like terms. 6x can be combined with plus 12x, and if I had 6x and added 12x, I now have 18x in the pile. I will box my negative 9, and I will box my plus 9, and just like above again, well, if you owed me $9 and you paid me back $9, you don't owe me anything. Set that equal to 180. Yes, we will just simply divide each side by 18. Wonderful work you guys are doing. Incredible. X equals 10. No, that is not our answer. All right, so let's go ahead and take a look. Find the measurement of angle 5. Well, we're just going to plug into 5 since they are supplementary and they're different size. All right, so let's open up a 3. All right, you'll open that parenthesis. We will drop a 4. Now, for your calculator to recognize this, you will have to open up another parenthesis. Okay, that's not a close, that's another open. Drop your 10 in there. Close it off. Put in your plus 3. Close it off again. All right, so we're just following it. Equals. So let's go ahead and put that in. 3, open. 4, open. 10, close. plus 3, close, enter 129 degrees. Let's keep on moving forward. Okay, what is the measurement of angle A? Wonderful. All right, I love how that gives us all of this stuff here. The exterior angle of a triangle is equal to the sum of its two remote interior angles. Awesome. So that means this exterior angle of 132 is equal to its remote angles. Now, C's not remote because it's right next to it. Now, remote's like, hey, we're working from home. We're not working in the building where the interior would be in the building. So if we were working from home, it would be B and A are your remote angles. So if you just simply do 132 minus 82, that gives us 50, and that is the measurement of angle A. Go ahead and circle B as your answer choice. Okay, again, isosceles triangles. All right, so we have two sides that are congruent, and the two angles on the base are congruent as well. That's why I did the blue and the blue. Now, we do know that the three interior angles of a triangle total 180. Now, if we're solving for A here, well, it's giving us C, but B is the same as C. Finkel is Einhorn. Einhorn is Finkel. All right, so minus 52 minus 52, 180 minus 104 leaves us exactly 76. Circle your answer. Moving on to number 20. Okay, we are going to see something very similar to this equilateral, okay, of two triangles. Here, I already just left the answer, and I left a note here. All right, AC is twice the size of XY. So if AC is 46 and it's double the size of XY, well, 46 divided by 2 equals 23, which gives us our XY. Continue to move forward. Okay, moving forward for numbers 21 through 24, okay, for this intro trig section, I want you to really just take a look at what I have presented here. We have our sine, cosine, and tangent, our SOHCAHTOA, okay, our opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, now the real kicker to these three is, again, the same of all of math: identify, recognize, sequence. Okay, so we will identify your sides as hypotenuse, opposite, and adjacent. Recognize what you're solving for to select formula. Basically, are we working with sine, cosine, tangent, or are we working with the inverse? Okay, so a couple of different formulas that you will see is when solving for an angle and provided two side lengths, use the inverse function. So on our calculator, let me clear that off. You will hit second first and then hit sine, cos, or tan after you set it up. Okay, and then number 2, when solving for a side, set up an equation with the angle measurement and side length provided. So let's take a look at these next few. Okay, I've also built these in. I really just wanted to give you a good tool to utilize, all right, to take advantage of here. So it says find the cosine of angle B. So this is like a total warm-up, okay? This is just asking us to identify the two side lengths that go with cosine, and then just to do the basic math to it. Okay, now the first thing I like to do, so let's just take a look at this example in notes first, okay? Hypotenuse is the side opposite the right angle. Find your right angle. All of these will have the right angle. Directly opposite is your hypotenuse, okay? Opposite is the side opposite the angle you are solving for, or what it's asking you to find for. So in this case, it's angle B. I'll find angle B. If I go directly across the opposite, we get 30 for its opposite side. The other one just simply being the adjacent. I always try to find the hypotenuse and opposite, and then I just know the adjacent is there. But just in case it is directly connected to, it shows an angle, which is B, and is not the hypotenuse. So it's clearly 40. Now it's asking us for the cosine. So we're not looking for opposite over hypotenuse. We're actually looking for cosine, and we are looking for adjacent over hypotenuse. We are just simply doing a real quick fraction just to introduce it and to find it, okay? So our adjacent side of angle B is 40. you will put that over the hypotenuse, which is 50. Excellent job. And in your calculator, if you do 40 over 50, you're going to get an answer of equals 0.8. Go ahead and circle your answer. It's all you have to do for that one when it says find, because there are no angle measurements outside of the 90. Okay, so for number 22, solve for the measurement of angle A. Whoa, okay. So what we have done here is, first thing, what I like to do is identify. I always start with my 90. I always go directly across. Let me grab my red marker, or red pen. And I'm just gonna put hype. Okay, so it's definitely providing us that. Then if we're solving for the measurement of angle A, I'm going to look for angle A, and I'm going to go directly opposite to find my opposite side. Now, we could label side AB adjacent, but we're not solving for that side. We're actually solving for the angle measurement. And when we're solving for an angle measurement, I'm going to go back up to our cheat sheet here, okay? And provided two side lengths, which it's given to us, we will just simply use the inverse function. All right, now I have written these instructions here for us, but let's just go ahead and set it up and see what angle A is providing us. Well, angle A is providing us an opposite and a hypotenuse, okay? And if we look at sine, it provides us opposite over hypotenuse, okay? So I'm just going to simply write this out first just so you can see it, all right? We will want to do sine. And when we see that -1 above right there, that's telling us the inverse, okay? So now we just type in your calculator will auto dispense an open parenthesis, and then just go ahead and put in your opposite, which is 10. Hit your division symbol for that /. Put in the number 14.5 for your hypotenuse. You don't have to close the parenthesis. I just suggest it just in case you get a little confused there. But let's just go ahead. We will hit second in that blue key. Then we will hit sine. Then we will see that it did open the parenthesis. Type in your 10. Type in your divided. Type in 14.5. I like to close it. Hit enter, 43.6. We will take that number, we will round it to 44, and circle C is our answer. And just in case you do want to pause the video real quick, there you go, there's a quick little recap. And for 23 here, when solving for a side length, we will have to set up a quick equation. So a 14-foot ladder is placed against the wall, so it's leaning up against the wall. The ladder is on level ground at an angle of 70.5, so there's our ladder, it's on the angle of 70.5. to the horizontal, okay? About how far up the wall, so here's our wall, will the top of the ladder be located? So we're looking for the peak right here, so we're just looking for the height or the side length of X. So you will have to draw this out. Now again, let's go take a look back, all right? Whoa, when solving for a side, set up an equation with the angle measurement and side length provided. Okay, well again, what do I always like to do first? Well, hold on, let me actually finish that. I somehow ruined that when I went back over it. All right, I always like to find my hypotenuse first. I go back to the problem and I'm like, well, I'm looking for an angle of 70.5. All right, so I'm just gonna go directly across that. That will give me my opposite. And again, it's giving us the OH for that sine. All right, so when we use this, what I want you to do is, in your calculator, or, well, let's first set up the equation. Here's how we write the equation. We use sine, okay? We will open a parenthesis. We will type in our 70.5. We will close it, equals. All right, now we have to set it up. Well, it's opposite over hypotenuse, so it'll just be x over 14. Now, what we can do to clear that fraction is multiply everything by the denominator, which in this case is 14. I'll switch to the color pink just to show that to you. So times 14, and then when we do that, we can cancel out our 14s, but what we do to one side of the equation, yes, we also do to the other. So then when you enter this in your calculator, you're simply just going to do 14, hit times, hit sign, all right there. It auto opens, type in your 70.5, close your parenthesis. All right, then we will just hit enter because now we have our x is what we're solving for, and we have 13.19, and go ahead and circle A as your answer. So equals 13.19, and A will be your answer. So for number 24, the height of a tree measures 70 meters to the nearest degree. What is the angle of elevation of the sun when the tree casts a shadow? That is 60 meters long. Here's our shadow, here's our tree, here's our angle of the sun. All right, it's looking for an angle measurement. So again, we will use the inverse, but let's identify sides first. I start with my 90, I get my hypotenuse. All right, I know what angle it is providing us here. We do have our tree of 70. All right, we do have our opposite going across there. And then we have our adjacent. So what it's giving us is opposite and adjacent, so that will be our TOA, our tangent. All right, so tan gives us the OA. So when we do this, we're just again going to hit that second function on our calculator. All right, then you will hit tan, and as you can see, it'll bring up, oh, I didn't hit second, so second, let me clear that out actually, second, then hit your tan, and now we can go ahead and I will write it just so you guys can see it as well. That will open up your parenthesis, and if it's just opposite over adjacent, well, we'll just do 70 over 60. And then hit enter in your calculator. Divided by 60, close it, enter. Now we have 49.39. We will simply round that to 49 degrees. Now to find the value of W here, big kicker, central angle is the same as the measure of the arc. So 2W plus 18 equals 5W. We're just setting up a basic equation here, and this should be super simple. This should be a flyby for all of us who are great at solving equations, which you all are. Subtract 2W from each side, bring down your 18, equals 3W. Last step always is just to divide by that coefficient of the variable, which is 3. 6 equals our W. Go ahead and circle C is your answer. For 26, real quick, find the values of x and y. Okay, so the inscribed angle is half the measure of its intercepted arc. Our inscribed angle is 33, all right? Its intercepted arc is double the size of this. So you're just doing 33 times 2, which gives you 66 as your answer. And if you look at x, it's clearly 90, because if we ran a straight line here or here, we know that lines are 180. So your answer will be x 90, y 66. So for the next one, same kind of deal. Find the value of x. Well, we have an inscribed angle. Take a look at this, like a little baseball diamond, okay? And here's our home run fence in green. That's our intercepted arc. Now we know that intercepted arc, if from the time before, is double the size of our inscribed angle. And our inscribed angle is 105. And if our intercepted arc is double, we just multiply 105 times 2, giving us exactly 210. All right. Oh, an arc segment of 120. And then, so we're just going to subtract. We'll take our total of 210 of our intercepted arc. We will subtract it by the arc segment it's giving us, which is 120, making our answer 90. Go ahead and circle B. For 28, moving forward, quick Pythagorean theorem here. I just want you to see the triangle pretty much. Okay, then we will just plug and chug. I rewrote it. I don't want to focus too much time on this because the 11 plus 7 gives us our 18, which is also our hypotenuse directly across. Okay, you can label either or AB. I decided to go A here, B here. When we solve for B, we just do the square root of C squared minus A squared. I set it up for us to solve. In your calculator though, hit second, then hit x squared. That'll bring up your root. Oh, let me clear all that. Let me hit second. X squared. All right. Then we open our parenthesis. We type in our 18 for C. Subtract. Open a parenthesis. Oh, delete. Forgot to hit x squared. Thank you guys. Appreciate it. Minus. Open a parenthesis. Put in your 11. Close it. Hit x squared. Hit enter. We get 14.247. Go ahead and circle 14 units, and just in case, I will put it here as well, and here, giving us our 14.2. Go ahead and circle 14 units. The large circular table has an area of 400 square feet. Was a table circumference? All right, I just did the formula for us. We're going to take 2 times the square root of pi times area. Pi is just represented by 3.14, so in our calculator, again, this is a simple plug and chug. Type in your 2, hit second, hit x squared. Type in your 3.14. Let's go ahead and read through the problem. Well, a large circular table has an area of 400 square feet, so our area is 400. We just plug that in. All right, so open a parenthesis, 400, close it, hit enter. We get 70.88, which gives us our circumference. Sorry that I'm just kind of rushing through, but ones like this where I've added the formula, if we just plop that in and we know exactly what to plug and chug, well, it's just a calculator problem. It's very quick. And for 30, a circle has a radius of 79 units. Find the area of a sector with a central angle of 91 degrees. Again, I've written the formula for sector area. We will take our radius squared. In this case, it's 79. We will then open a parenthesis, put in our central angle of 91. All right, you multiply that by pi divided by 360. Again, pi is just 3.14. Ballpark. Okay, so we will type in our 79. We will square it. We'll open a parenthesis. We will type in 91. We will close it. We will open another one. We will type in our 3.14 divided by 360, a full circle. Close it, hit enter. We get an answer of 49.53. And go ahead and circle C as your best answer choices. Clearly, 8s, 2s, and 1s will not work for us. And that completes your review. Let's go.